Hello everyone, in this video I'm going to show you about half a dozen practice problems how to actually use these conversion factors in actual calculations. In the half a dozen practice problems I'm going to show you the math step by step. We're going to start easy with an easy number, and I'm going to then change things up a little bit, and we're going to end with some practice problems that you can do on your own, but the last slide is going to show you the answers to those practice problems, and we'll discuss why those are the correct answers for those practice problems. So that's the lay of the land for this video. A number of things I want to mention before we get going. One, the math is easy. It's not rocket science. The math is actually a one-step calculation. That means that you're going to have one number to either multiply with one of these conversion factors to get a final answer. That's a one-step calculation. Or you have another number to divide one of these conversion numbers by to get your final answer. Also a one-step calculation. So the math is very doable, yes? One-step calculation. As you can see from these calculations, these conversion factors relate gallons, cubic inches, cubic feet and pounds. There's nothing metric here. Metric conversions is a completely different topic in a completely different video. This is not about that. These are conversion factors that convert the units that you see on the board, and these units are featured in the US customary system as well as the imperial system of measures. Spoiler alert, there are two different systems that use the similar words or same batch of words in different quantities. There are two different gallons in commercial use today, as in 2019 May the 2nd. So why there are two different systems? What's an imperial gallon? What's a US gallon? What's a cubic foot and a cubic inch? Those are brilliant questions. The explanation for these questions are in a completely different video. It's a 20-minute video for which I'm going to include a link in this video's description box below. I also explain in that same video what the meaning of these numbers are. None of these numbers are random. There's a reason why this is 10 or a reason why this is, I don't know, 7.48. Those explanations also in the same video. You're very welcome to watch. It's actually a very good investment of your time, well worth watching, because you need to have a clue about the context of these conversion factors. You need both. You need to know how to do the math, and you also need to know what these mean in their context. One more thing about the numbers is that three of them are whole numbers. This one here, this 10 and 231. The rest of them are decimal figures. In your line of work, in your industry, the decimal numbers may be rounded differently. All of these decimal numbers are infinite decimal numbers. That's why they are in the explanation video. And the infinite decimal numbers need to be rounded. Depending on the required precision in your industry and your line of work, the rounding of these infinite decimals will differ. This might be 62.42 in some of your textbooks. If it's so, I'm not arguing with your textbook. I'm just pointing out that between different industries and different occupations, these figures can be rounded differently according to the precision required by the task that you're actually doing with these numbers. So this one here, 277.42, sometimes it's just listed as 277. If it's so for your line of work or for the task that you're doing in your line of work, then just work with it as your textbooks say so. If it says just use 277, just use 277, and that's it. I'm not telling you otherwise. Regardless of how these numbers are actually formatted, the math is the same. There's only one math to do, whatever your conversion factors actually are rounded to or look like. Three of these conversion factors are different out of all of these. The ones that end in pounds. There are three of these numbers. Here is one, the second, and the third. These three numbers in this lineup of conversion factors relate to water. That's ugly, I'll fix it. I'm writing H2O there. H2O for water. Whether it's hot water, cold water, there is a specific conditions that these numbers relate to, and in this math context it doesn't matter what they relate to at the moment, but they relate to water. If your liquid commodity in your line of work is not water, but instead you're working with gasoline, aviation fuel, turpentine, battery acid, shampoo, or liquid soap, milk, or I don't know, palm kernel oil, just to name a number of other liquid commodities, you will have all the other conversion factors, but these three will be different, because these three that I circled depend on the type of liquid commodity. 1 cubic foot of liquid concrete, or solid, whatever, you can wait until it solidifies, is 150 pounds. So that's a vastly different figure than what you see here. So if you're working with, I don't know, molten lead, these will be vastly different from what you see. But if you're working with milk, which is not too dissimilar from water, then the figures will be reasonably close to these figures, but will be different, guaranteed. I would like to invite you to share your specific conversion factors in the comment section below, and the industry you work with, how they are different, what kind of commodities you work and you need to convert typically. If you have some difficulties or some memorable glitches and some memorable learning experiences that you want to share with other learners who are looking for some help with this conversion stuff, please share your stories as well as your conversion factors that relate to your specific industry. All the other conversion factors are unaffected by the industry. 1 US gallon will always going to be equal to 231 cubic inches, no disagreement whatsoever, because it doesn't matter what the 231 cubic inches are filled with, whether they are filled with compressed air or liquid gold or whatever, solid concrete. It doesn't matter, it's always going to be 231 cubic inches. So, with that said, we are good to go for math. The first thing that I want to point out about math, and I can't really sugarcoat this, you have to memorize your conversion factors that are unique to your industry. Whether you are a metal fabricator, boiler maker, pipe fitter, plumber, sprinkler fitter, pipe fitter, a number of occupations that work with these conversion factors to construct storage vessels that store these liquid commodities that I mentioned and others, you need to memorize these numbers, okay? And this is not a video in study tips, but whether you memorize it alone with flashcards, or whether you quiz each other between or among students in a group, or how you want to maybe force yourself to do practice problems and force yourself to look up the correct conversion factors that are needed for the practice problems. Whatever approach you have, only you know what's going to be most effective to you, and you're going to need to probably find it by a little bit of experimentation if you don't already know it. So memorizing these conversion factors is not an extraordinary task, but this is something that you have to do yourself, and you have to find it out for yourself what works out best for you. You are likely to be different from your best buddy or the guy next to you. Step 2, or I don't know, item number 2 that I want to point out, you also have to memorize all of the words that are on the board that these conversion factors relate to. You have to remember the meaning that the 231 conversion factor relates US gallons to cubic inches and not anything else in any random order. So line by line, the words need to be remembered with the conversion factors. These units of measures are critical, and this is where my memorable story comes in. In 2 words, Gimli glider. Gimli is an abandoned Air Force base in Canada where a commercial jet had to emergency land because it ran out of gas, aviation fuel, somewhere halfway between its destinations. The reason behind it is they put in not enough, too little fuel when it was fueled up for the trip. The workers calculated using a basic calculator, because that's all you need for, this is a scientific one, all you need is a basic calculator to do one multiplication with simple decimal numbers, and they correctly calculated that the amount of fuel needed is 20,000. The calculator tells you the number 20,000 on the display, but it doesn't tell you 20,000 what. If I take away the words, the problem is immediately obvious. 1 watt is 231 watt, or 1 watt is 10 watt. You need to memorize the units of measures with the conversion factors, the correct units of measures with the correct conversion factors. There's no other way around it. In the case of the Gimli glider, the workers guessed that the 20,000 was pounds. Unfortunately, they guessed wrong. The aircraft ran out of aviation fuel halfway through the trip and had to emergency land. It resulted nearly in the total loss of the whole aircraft and all souls on board. The exceptional flying skills of the captain saved the aircraft, which without fuel doesn't have any wing flaps or ailerons, no control surfaces, nothing works. There are no lights on the dashboard, you don't have any instruments, you don't have nothing in front of you. All you have is a glider, the Gimli glider, that's barely controllable. And you can't miss an approach, you know you can't circle back another time. You have to land on a fixed little runway on an abandoned Air Force base where, surprise, surprise, some families are having a vacation. So, please look it up, Gimli glider. I can't stress it enough, you have to memorize the words that go with these numbers. In case of the Gimli glider, they put in 20,000 pounds of fuel instead of 20,000 kilograms of fuel. Now, kilograms is metric, but a pound is worth half of a kilogram. So instead of enough fuel, they had half the amount, because pound is about half of a kilogram. No, so look it up, the Gimli glider. You need to remember your units of measures, because the calculator doesn't do words, it only does numbers. You have to keep in mind the context for the numbers. Alright, the calculations are fairly straightforward. On the left side of a calculation, there's the given information. On the right side here is the requested information. On both sides, there is a number or a quantity specified, and there's a unit of measure that you need to keep in mind. On the requested side of things, there is a quantity that you have to come up with using your calculator typically, and there is a unit of measure in which this conversion is requested. All of this relates to one common commodity, whatever you're working with in your industry. Here is how one practice problem looks like. This is the given side here, and that's the requested side. In this case, it asks that imperial gallons be converted to pounds. And you have, in terms of quantity, you have 5.1 of these, and we don't know it makes how many of those, hence the conversion. So how the math goes is fairly straightforward. You remember your conversion factor. Between imperial gallons and pounds, the conversion factor is 10. So that number 10 comes from your memory bank. You need to either multiply or divide this 5.4 by 10. This given number is always the first number that you enter in your calculator. This is the one you're either multiplying with your conversion factor or you're dividing by your conversion factor to get your final answer. That's the one step. Now, which one step is in this case? It's not rocket science either, but this is where memorizing your units of measures with the conversion factor is really, really important. The conversion factor 10 relates imperial gallons to pounds in this order, from the left to the right, and this practice problem is printed in the same way. Therefore, this is a multiplication. What you enter in your calculator is this. You copy the number correctly. Please make an effort to copy and enter the number from the given information from the problem into your calculator without a typo, and you multiply it. Again, I'm not insulting your intelligence, I'm just recapping that this multiplication comes from the fact that the conversion factor 10 relates imperial gallons to pounds in this order as the practice problem is printed. That's why it's a multiplication. When you multiply, and this one doesn't need a calculator, you just shift the decimal dot, but just for the example's sake, that's the calculation. Once the calculator shows you that final answer, do make an effort to copy it accurately. Now 51 doesn't take an Einstein or a genius to copy accurately, but when you have multiple digits, many of them are zeros or decimal numbers, whatever, large decimal numbers, make sure the answer is copied accurately, unless you like a Gimli glider. So that's how a calculation looks like. The calculation itself is easy, memorizing the conversion factors is not, and the calculator is not going to do the thinking for you to decide whether it's a multiplication or a division case. That thinking you have to do yourself. Here's another one. I switched the pounds and the imperial gallons around. This is a case where division is used. The reason why division is used is because the conversion factor 10 relates imperial gallons first to pounds mentioned second. In this conversion practice problem, the imperial gallons and the pounds are listed in reverse order. That's why this is a division problem. Okay, I hope that makes sense. It's fairly straightforward. Again, copy the number accurately once, do the calculation correctly, then copy the number back into your answer line without typos. Fairly straightforward. Let's look at another one. Cubic feet needs to be converted to cubic inches. Again, you need to remember your conversion factor, 1728 in this case. You also need to remember the order of the units, which units the conversion factor 1728 relate. 1 cubic foot equals 1728 of cubic inches. Therefore, because the conversion factor relates cubic feet to cubic inches, and this practice problem is listing these units of measures in exactly the same order, this is a multiplication problem. Copy the numbers correctly into your calculator, multiply, there's your conversion factor that you memorized, and make sure that your answer is also copied correctly to the answer line. Let's look at one more example here, pounds and cubic feet. The conversion factor in case of water, your liquid commodity might be different, but in case of water, this conversion factor is 62.43 or 62.42, depending on your source of textbook. I'm going to work here with 62.43. 1 cubic foot of water is 62.43 pounds at a certain temperature and pressure. The conversion factor 62.43 relates cubic feet first to pounds mentioned second. This practice problem lists cubic feet and pounds in reverse order. That's why this is a division. Copy the numbers correctly into your calculator and copy the final answer. You see, I'm kind of trying to play here with the number of zeros a little bit for making the decimal answer a little longer. It needs attention at the decimal place, whether it's a decimal dot or a decimal comma in your market and language area. however you write decimal numbers, but the decimal place and the leading zeros and the trailing zeros, whatever, needs to be correctly copied from the calculator. And of course, if you want to use just 2 digits or 3 or 4 is up to you as well. I'm just saying copy the numbers correctly. Again, this is a division problem because the conversion factor 62.43 relates cubic feet first to pounds mentioned second. And here in this practice problem, the cubic feet and pounds are listed backwards from right to the left, not from left to the right. There are 3 practice problems that you can do yourself. I'm gonna stay quiet here for 5 seconds, look up the conversion factors, toggle back to the beginning of the video. And the final answers are coming right here. In the first case, this is a division problem because the conversion factor 8.3 relates US gallons mentioned first to pounds mentioned second. In case of water, I do want to stress that if you're working, because this is pounds again, if you're working with a different liquid commodity, instead of 8.3 you're going to have a different number, most likely. And this could be 8.33, or again, different variations exist like I mentioned. But this is a division problem because US gallons are related to pounds with this conversion factor in this order, that first and this second. Over here in the middle, between US gallons and imperial gallons, there are 2 conversion possible calculations shown here. One with a multiplication with that conversion factor, and the other one is a division with that conversion factor. This is the only possible case where you relate imperial gallons to US gallons, where this is possible. If I can toggle back to the first slide, this one, you can see that both are given here. 1.2 and 0.83 are inverses of each other's, so it's possible to use in this calculation either one of them, but you still need to know, or still need to decide which one to use and what to do with that. When US gallons are related to imperial gallons, 1.2 is used in a multiplication. When imperial gallons are related to US gallons, 0.83 can be used with a division. The last practice problem here has only one way to solve it. The figure here, the conversion factor that you need is 277 or 0.42 or 0.12, whichever way this number ends. Again, this depends on pressure and temperature, but the conversion factor is here. And this is a division problem because imperial gallons are related to cubic inches with this conversion factor mentioning or listing imperial gallons first and converting to cubic inches after, and here they are listed backwards, so this is a division problem. So that's how these work, that's the flow of things. That's how the one-step calculation looks like with these conversion factors, and including the ones that you use in your industry. Like I said, please include some notes and comments below about your industry and your unique and specific conversion factors, and if you have any learning glitches, how you solve them, please share them and help others. Thank you very much for watching.